Okay, 471 wants us to solve these equations using any method. So let's start with A, right? So A is 2x plus 3y equals 9, and negative 3x plus 3y equals negative 6. So we could see that the 3y's line up. And although you're allowed to subtract the equations, I think it's better if we multiply the bottom equation, right, by negative 1, right, both sides by negative 1. So I'm going to rewrite the whole system. Top one stays the same, 2x plus 3y equals 9. And the bottom equation I'm going to multiply by negative 1. So I get 3x minus 3y equals 6, right? All the terms get multiplied by negative 1. Okay. So now I add 2 and 3 is 5x, 3 and negative 3 cancels out, equals 15, divide by 5, and we get x equals 3. And then we could go to any of the equations to find the other value. So I'll go to that top one. So I get 2 times x, which is 3, plus 3y equals 9. So 6 plus 3y equals 9. 3y equals, subtract 6 from both sides, right, equals 3, and then divide both sides by 3 and get y equals 1. So we get 3, 1 as the solution to A. Okay, let's do B. Let me clear this one. So for B, we have x equals 8 minus 2y, and y minus x equals 4. This one, I think that it's easiest to use substitution. So I'll take the 8 minus 2y and I'll substitute it in for x. So we get y minus the whole thing, 8 minus 2y, right, equals 4. Don't forget those parentheses. Then we have to distribute in. So I get y minus 8 plus 2y, right, negative minus 2y, equals 4. And then like terms, y and 2y is 3y minus 8 equals 4. Add 8 to both sides, 3y equals 12. Divide both sides by 3, and we get y equals 4. Then I'll go up to this top equation, since it's already solved for x, and I'll substitute in. So x equals 8 minus 2 times y, which is 4. X equals 8 minus 8, x equals 0. So the ordered pair is 0, 4 for B. Okay, for C, let's make some space. C, I have y equals negative 1/2 x plus 7, and y equals x minus 8. So this is kind of calling out to use equal value method. That's one way to do this, right? So I'll set them equal to each other, right? So I'll set negative 1/2 x plus 7 equal to x minus 8, because they're both solved for y, right? So then I'll add 1/2 x to both sides, right? So plus 1/2 x plus 1/2 x. So I get 7 equals, so I have 1x, or 2/2 x plus 1/2, that's 3/2 x minus 8. Add 8 to both sides, that's 15 equals 3/2 x. And then multiply both sides by 2/3, the reciprocal, right? 2/3, right? So that these can cancel. So for this we get 10, x equals 10. And then we have to go and substitute in. I'll substitute into that one, right? So we get y equals 10 minus 8. Y equals 2. So we get 10, 2 as the ordered pair. And the last one, D, let's make some space. D, we have 9x plus 10y equals 14. And the other one is 7x plus 5y equals negative 3. So this one, I realize if I multiply this bottom equation by negative 2, right, on both sides, we can get the negative 10y. So let's rewrite both equations. I have 9x plus 10y equals 14, and then the bottom equation becomes negative 14x minus 10y equals 6, right? Negative 3 times negative 2. So now I can add 9 and negative 14 is negative 5x equals 20. So x equals negative 4. And then we'll take it and we'll substitute into any of the equations. Let's put it in that one. So we get 9 times negative 4 plus 10y equals 14. So negative 36 plus 10y equals 14. Add 36 to both sides, we get 10y equals 50. And divide by 10, so we get y equals 5. So we're left with negative 4, 5 as the ordered pair.